1.6, okay? But the formula that we're going to learn today is going to be this formula right here. Okay, so this is going to be the distance formula. We're going to be given coordinates just like the midpoint formula. So we're still going to be dealing with our x1, x2, y1, y2. But go ahead and write that whole distance formula, and then we will discuss it. I will go ahead and write it on the board if you cannot see it. But you definitely will need your calculator today. So if you don't have that out, go ahead and get that out. All right, there is your distance formula. So just like the midpoint formula, we're going to be given two sets of coordinates. But with the midpoint, we're finding the middle distance. Okay, we're in between the 2 points. This time we're going to find the full distance. We're going to be using square root this time. So just be aware of that. The biggest thing that a lot of people forget is the square root sign. So you got to remember that everything on the inside is inside of the square root. Okay, do we all have this formula written down? All right, so let's go ahead and look at an example together, okay? So what we're going to need to do in this example is we need to find FG and JK, and we need to determine if the two segments are congruent, okay? So the first thing that we need to do is we need to find the coordinates of these letters. So maybe those of you that are closer, you might see a little bit better. But can anyone tell me what are our coordinates going to be for G? Yeah. 5, 5. All right, Jordan, what about F? 1, 2. Okay, J? Who can tell me what J is? -4, 0. Okay, and what about K? Yeah, Julian? -1, -3. Okay, so there's going to be some cases where you're actually going to need to find the coordinates, and then some cases where you're going to be given the coordinates. So let's make sure that these match. Okay, we got 1, 2, 5, 5, -4, 0, -3, -1, -3. Okay, so now let's go ahead and we need to find the distance of the two segments. So we're going to use the distance formula. And let me go ahead and erase those coordinates. Okay, so we're going to be using our equation. We're going to be plugging in our coordinate values. So let's go ahead and look at this. So if we have F and G, okay, we go back. All right, F is 1, 2, and G is 5, 5. So we're going to start with FG first. Okay, so if we're plugging it into our distance formula, what is our x2 minus x1? Yeah. Well, we'll do 5 minus 1, yeah. And what about y2 minus y1? What would it be? What minus what? 5 minus 2, okay? So it should look just like this, all right? And we got to make sure we do PEMDAS, so like you guys said earlier, we get 4 and 3 because we need to subtract first, okay? So it's going to look something just like this. So we have 4 to the second plus 3 to the second. So what's 4 to the second? 16. What's 3 to the second? 9. Okay? We get 16 plus 9. That's going to be 25. And the square root of 25 is going to be 5. All right? this is just one of the examples where, okay, our square root is going to end up becoming a positive value. Most of the time when you do this, let's say our answer was square root of 26, okay? We would keep our answer as square root 26 and not make it a decimal, unless it tells us that we need our answer as a decimal. So most of the time, you're going to just leave your answer as a square root unless it becomes a whole number, all right? You're going to have examples where you're going to leave it as square root. You're going to have examples where you need to get the decimal. Okay, so let's go ahead and JK. All right, so if I go back, let's look at our values of J and K. We have J is negative 4, 0. I'll go back to that last one. K is negative 1, negative 3. All right, so if we're plugging this in, what are our two x values? What's our two x values that we have? Yeah. Negative 4, negative 1. What are our two y values? Yeah. 0, negative 3. Okay, so let's go ahead and plug that in. All right. So in this one, we have negative 1 minus negative 4. And then we have negative 3 minus 0. Okay? What happens when we have minus a negative number? What's going to happen? Yeah, you're going to end up adding. So when we have minus a negative number, it's going to turn into negative 1 plus 4. What's that going to be? 3, okay? What's negative 3 minus 0? Negative 3, okay? So then we have 3 squared plus negative 3 squared. Okay, so when we have 3 squared, what's that going to be? What? 9. And what's negative 3 squared? Is it positive or negative 9? It's positive. Because when we have a negative squared, it's going to become positive because it's like negative 3 times negative 3. So you need to make sure whenever you have a negative number, it's going to be positive. Okay, a lot of people mess that up when they solve these. So we got 9 plus 9, so it gives us square root of 18. It just went ahead and simplified the radical, okay? But we're not going to worry about that now. I would just have you leave your answer as square root 18. All right? Okay, so in this case, those two segments are not congruent. They do not equal each other. All right, let's not do that. Okay, so let's go ahead and give me 1 second to switch this. Gosh dang it. All right, so let's look at some examples together. All right, let's look at this. I'm going to put it in landscape so you guys can see better. All right. So if we're looking at this one, all right, we need to find the distance between the 2 points in simplest radical form. Okay, so on this first one, all right, it is going to be our coordinates. It's going to be 3, 4, and negative 1, 0. Okay, you'll be able to see it better when you do your homework. All right, so who can tell me how we can set this up into our distance formula equation? Yeah, Julian. Yep, but what do I need to do for the whole formula? How am I going to plug this whole thing in? Who can help him out? It does not. Nope, because you'll still get the same answer. So anytime, yep, the x's and y's, it doesn't matter which one's your 1 or 2, you'll still get the same answer. When we put this in equation, we got to make sure we do the whole square root. Okay, so who can tell me how we can do our x's first? Yeah, Rebecca? Not plus. Minus 3 squared. Then it's plus. Who can tell me our y's? Yeah? Yeah. We're going to do 0 minus 4, so that way our 1s and our 2s are the same. Okay? You're still going to get the same answer, but I just want to make sure you guys kind of just use your x1s and y1s as the same. All right, so we have -1 minus 3. What's that going to be? -4 squared. 0 minus 4? It'll be -4 squared again. All right, but then when we do -4 squared, what do we get, Willow? Yep, positive 16. I'm going to go ahead and just make that 6. Plus 16. All right, and then what is 16 plus 16? 32. Can we simplify this anymore? Or can it become a whole number? No. So I would have you leave your answer like this. Okay? All right, what about number 3? Let's look at number 3. This one we got to pay attention because it says find the distance between the 2 points rounding to the nearest tenth. Okay? So do you think we'll be leaving our answer as a square root? No, not in this one. All right, so who can tell me how we can set this one up in an equation? Someone else. How can we set this one up? Yeah, Tanner? -1 minus 2 squared. Then what? Yeah, we got to do plus 1 minus -3 squared. Okay? So who can tell me what -1 minus 2 is? Yeah, Rebecca? -3 squared. What about 1 minus -3? What's that going to be, Esme? 1 minus -3? Well, what happens when we have minus a negative? So what does that give us? 4. Perfect. 4 squared. 3 squared is 9. -3 squared is 9. Plus 4 squared is 16. Square root of what? 25. Does that come out as a whole number? So our answer is 5. Okay, so this one ends up not being a decimal. Okay, but we would do the square root no matter what. All right, so let's get this. I want you to do these two on your own. All right, I'm going to give you the coordinates because it's kind of hard to see. This is -6, -2, and 3, -8. So go ahead and solve. This is number 2 and 4. Go ahead and do those.